Okay, so here's the near field microwave imaging scanning table. As you can see, there's two stepper motors back there. These stepper motors are controlled by this Arrick Robotics C4 controller, and the stepper motors are driven by this MD2 dual stepper motor driver. Okay. The problem was when we had a sample or a piece of metal on here, we would raster scan it, and then at each point we would take a DMM voltage measurement. I'm not going to get too much into the specifics, but the problem was syncing these two things. We used one computer here on the left to control the motor, and we used one computer here on the right to control the data acquisition software. The problem was, how do we synchronize between motor movements and data acquisition? Okay, so after looking at the C4 controller user's guide, I noticed that you can invoke commands, ASCII commands, through the serial bus on the back of the computer, which is, in this case, is RS-232 compliant. As you can see, it attaches to the back of the C4 controller. But again, you can invoke movements using ASCII commands, and terminating those commands with a new line. So, our data acquisition software is written in MATLAB. So I used MATLAB and then opened up a serial connection with the controller. Here's my script, and then I'm going to run it. It pretty much goes through a for loop 50 times, and each time through the loop it turns motor 1 50 steps, and it turns motor 2 50 steps. And then at the end of my script, I tell it to return the motors back to the home position. So let's see what happens. So as you can see, the motor is going through the loop, 50 steps per each motor. And then soon it should return back to the home position. So it'll stop once it hits the limit switch, and then motor 2 will home until it hits the limit switch. There you go. I think this is a pretty good proof of concept. It'll definitely work when this feature is incorporated into the data acquisition software.